Do you know how smart contracts coupled with blockchain technology can automate processes and operations, eliminating common middlemen? Suppose you are wanting to rent an apartment. This agreement can be set up through the blockchain by paying in cryptocurrency. Receipts and transaction details are sent to both parties and held in a virtual account. The landlord sends you the digital key, which will grant you entry access at the specified date. If the key doesn't come on time, the smart contract releases you a refund. If they send the key before the rental date, the function holds the key's entry access, simultaneously releasing the fee to them and the key to you when the date arrives. The system works on a conditional if this, then that premise and is witnessed by hundreds of people because of public ledgers. If the key is given, the payment is sure to be released. If you send a certain amount of bitcoins or any other agreed upon cryptocurrency, you receive the key. The code cannot be manipulated by either party without the other knowing, since all participants are simultaneously alerted. There are no real estate broker commissions because of the direct nature of the agreement, no lawyer fees for every standard contract, and no real estate boards and tribunals to argue your case for non-payment or breach of contract. The process gains efficiency and security to the operation. Nick Szabo in 1996 described a smart contract as a set of promises specified in digital form, including protocols within which the parties perform on these promises. And this definition still describes the term. While a standard contract outlines the terms of a relationship, usually one enforceable by law, a smart contract enforces a relationship with cryptographic code. Today, our session will be run by Suresh Kandula. Suresh is a Senior Director of Technology from the New York office and has been with Sapient Consulting for 18 years. Suresh works on New York-based delivery engagements and supports multiple business groups and practice areas across North America, including data management and fintech. Suresh's primary responsibilities are working on delivery projects focused on technology strategy, enterprise, Java platforms, financial modeling, including MATLAB, Octave, and traditional legacy data warehousing projects. Within Sapient, Suresh has been actively helping build proof of concept and POV material alongside teams in India and New York offices. Suresh, along with BenchLab support in New York, worked on Ethereum, Symbiont, and Chain.com commercial platforms. Before I pass it on to Suresh, I wanted to mention that the first blockchain fundamentals video that we did will serve as a prerequisite for this lecture. It is better to have an understanding of blockchain and distributed ledger fundamentals before moving on to smart contracts and seeing some of the coding examples that Suresh will be running through. So I urge you, if you feel like a fish out of water on some of the concepts Suresh will be talking about, go back, watch that video first, and then move on to this one. So without further ado, I'll pass it on to Suresh Kandula.
Okay, so let me get started. Just based on the poll, I'm going to spend some time going over, kind of the intro topics, but I definitely would recommend everyone to check out the previous session, the YouTube link that Vladimir posted on the meeting invite. So I'll spend some time on the blockchain fundamentals in terms of architecture and approach. The way at least I would like to do things, at least for this meeting, is I have some demos of different applications that we have built here within Sapient. I'd like to go through some of those. Some of them are very simple ones, not really domain specific, and some of them are domain specific. So maybe that will also give some of the people who answered either A or B a little bit more insight into it, and then we go into some of the coding aspects and also the architecture. Okay, and as Vladimir mentioned, I will use the chat window, so I'll just checkpoint once in a while, and if Vladimir is checking, that's great, but I will checkpoint in between to see if there are any questions, and I will try and answer them if those are new questions. Okay, so I'll get started. Hopefully everyone can see me, see my screen, and can hear me fine. So we'll start with the topics. So for folks who are in the 9%, you are already familiar with kind of a centralized architecture in terms of mainframes, our client-server models, where everything, all the compute and data is stored in one place, or one server, or one data center. And then from that we move to more distributed environment where it is multiple web servers, application servers, data is stored separately, compute is done somewhere else. So into more distributed computing environments. So those are the two phases that you guys are already aware of, and most of you have worked on them. And where blockchain as a platform will take us to this third stage, which is decentralized, meaning the data is in all of the nodes, as we call it. So it's a decentralized network of computer. So some people call it a universal computer, but there is no server model here in decentralized platform. So everything is a node. So everyone is a server and everyone is a client. So that's a decentralized approach, and hopefully you will see some of those examples as we go through it. So that's kind of the basic premise. But it's not something new anyway. So the decentralized concept or platform has been in existence for some time. So if I go to the next slide, so Skype, it can do a lot of the things in a decentralized way already, except for organizations who want LDAP type authentication or authorization. The Apple AirDrop is a decentralized network where you don't need a central server where multiple iPhones can connect and talk to each other and share data that is available on other iPhones. So decentralized is not a new topic or new concept. There's a lot of historical platforms that use decentralized concepts. What we will see more in the next few minutes is in terms of a business application or that is more cryptographically sound platform around that. But the concept is decentralized, meaning there is no single server. Everything is a server. Everything is a node, is a client. So that's where we'll start our conversation. For folks, again, what is a blockchain? And one of the main reasons a lot of people, have their own understanding and may not connect with each other, because the blockchain as a platform it does a lot of things, and depending on what your expertise is, you might pick on one or two things that relate to you, and then that's how you associate blockchain to. But in reality, it's all of those things that you have heard or your colleague have heard of. So first of all, it's a peer-to-peer network. So that's a decentralized platform where anyone can join that network and can conduct operations or look at the state in a shared manner. So that's a peer-to-peer network. And then it's a distributed database. Don't use that as a distributed database only, but it's a distributed database. And you will hear this append only, meaning you can only write transactions to it, and those transactions in turn will be used to change state in your network. So we'll discuss more about that as part of the demo and also as part of the code walkthrough. And then there are many cryptographic elements to it, meaning whenever you call a method on the network, you need to present your key, or you need to submit someone else's public key, or you need to present your own signature of that transaction message. So whatever the case may be, it's secure, meaning you need to have your private key available, or you need to have someone else's public key available to actually transact on the platform. And consensus, that's a term that you would use often, but I generally prefer that to be a black box because we focus on application development on top. But rest assured that the state gets reconciled and a single version of truth appears at some point eventually. But that's what consensus is, whatever the mechanism may be. But given that it's a distributed database of sorts, you need to make sure that everyone is looking at the same state. So that's what consensus does, and everyone can agree on. And then there are a few other things, that it has. I'm not going to go into a lot of the details now, but I will cover them. But the key takeaway from this slide is there are a lot of things that blockchain does, and it's not a master of any one of those things. So it's a jack of all trades, and that is the power and beauty of it. It's not really, it's not the best database in the world. It's not the best network in the world. It's not the most fastest one. It's not the most, easy, user-friendly one. But it's all of those to some extent, which is what it makes it unique. That's kind of the intro, but I'm hoping I could get these points across to you in a more, meaningful way in the next few slides, but this is for your reference that you can read later and also understand a little bit more as we go through it. Okay. So one of the main, again, concerns from our clients as we present, so within P.S and Sapient, we are presented to like 20 plus clients in terms of what we have done, what our understanding is, how it will help our clients in terms of what they want to do, because everyone wants to hear about it. It's one of those things where once you start trying to understand and peel the onion, you'll say, oh, I can use it for X or I can use it for Y. So, you have a hammer in your hand, everything looks like a nail, right? So we need to be cautious in terms of explaining to our clients what use cases are actually relevant for them and what should be tried on blockchain, what should not. There are a few, rule of thumb things. So first of all, you need to have multiple organizations or business processes or line of businesses on the network. Otherwise, you can't just build a single node and use blockchain, because you could do it in other ways. You could do it in many other ways, probably faster and cheaper. But where the blockchain platform will be of use for you is if you really have multiple lines of businesses within your organization or multiple organizations externally to your organization that is trying to collaborate and share state and reduce some of them, enterprise data integration, file transfer, message queuing across enterprises and cloud. So those kind of things will be could be streamlined with blockchain, and you need to have a network effect to be able to leverage the platform. So that's a rule of thumb, but there are a lot of exceptions to it, but that's kind of the starting point in terms of when you should use it. So what I like to do is, before I go and explain a whole bunch of other theory, I want to spend some time showing some demos and walk you through why that is different from your traditional applications. So let me just go back. So I'll start with this. Hopefully this is an easy start. Hopefully you can see the screen. If you don't see the screen, just send me a chat. So this is a application that we built on one of the blockchain platforms. We'll go into the details of these. But this is a decentralized chat platform, meaning, it's like any other chat platform, but, this is encrypted and it is decentralized and it is peer-to-peer, meaning I could use it instead of a Bloomberg chat window. So I can have multiple investor banks, buy-side, whoever wants to get onto this network can set up their own node and can chat in an encrypted fashion with anyone else who is on the network without going through a single central counterparty to authenticate. So that's cool in the sense that obviously you might say, okay, I could do this thing in 10 other ways, in 10 other platforms. Why do I need blockchain for that? So the main reason I would say is, one, there is no single central party who is looking at these messages, and these are cryptographically secure compared to any other platforms you might use. And you could also have a regulator on the network looking at these messages that could only be available to them based on their privilege, and they can verify the compliance in near real time. And when a regulator comes and asks, give me all your chat windows, chat messages, then you can say you already have it. Like you can do whatever you need to do with it. And you don't need a platform like Bloomberg Chat and pay for it. Right? So that's a simple example. And you can continue on that, but with a different use case. But really the power of this platform is you can use it for many different use cases, but it's very simple, and it's not something that you can show me any other way. and I can prove it to you, that you can use any other platforms at this same fast, low cost and fastest way to develop, and that gives you the business benefits that this would give. Right, so when we present this to our clients, they are usually very excited to hear, it's also pretty simple to explain. So what we're doing here is we're putting all these chat messages on a distributed ledger, and some of it that Vladimir went through in the last session in terms of hash and block and all that. Right, so we'll get into some of the more nitty-gritty of that, but this is a very simple example. Right, so you can do it very quickly. There is no smart contract code in it. It's basically you're putting these text messages as transactions on the distributed ledger, and then you scan for it, and then you can find whatever you want to find based on the channels that you create to put the messages. And only the guys who would need to see it would see it, and only the guys that you want to send it to, you can send it, and you can give permissions and all that. Right? And that's what that is. So that's a very simple example. So I just want to make sure that you have the network effect question, and you have the cryptography, you have a decentralized, you have a database, meaning it's keeping all this data, which is your chat messages. So all of the features of a distributed ledger technology is used, and built this application. Anyone can deploy in their own node and then connect to this network, peer-to-peer, and then can chat. Right? So that's a simple example. Okay, I'll show a little bit more, conceptual. Let me see if I can show this. Okay. Let me know if you can't see it. I can try and find answers. So there's no questions yet. So this is another platform that we POC'd, which is a OTC trade derivatives platform where multiple banks can be on the network, create these bilateral trades amongst each other, and then immediately get confirmed. So you don't need a confirmation platform. Immediately can get transferred to your internal trade platforms, and everyone is sharing the same state. If someone edits, event can be generated to the other node, and they can also check the latest and can do it. So I'm fast forwarding it because we get into this more details, but I wanted to give some context to you guys in terms of what is possible with blockchain that might not be possible with other platforms, at least at the same cost and speed and trust. So that's another example. So this is a lot more detail, meaning there is a lot more logic in it. Not a lot more, a little bit more logic. There is forms, there is state, meaning pending approval, that kind of thing. So it's another example. So this does have a smart contract, meaning there is code involved, and we'll get into some of the details. Okay. So that's the second example. So those are the two things I wanted to show, and we'll get to these in a bit. Let's see if there are any questions. If you keep all the chat messages, won't storage be required on each node? Okay, so that's a good question from Mario. So short answer is yes, but the long answer is they are evolving really fast, meaning these platforms. And there are a lot of things that you could do only on a bilateral storage, what called private channels or private messages or private transactions. So your question is valid, but we are in the version 1 of this platform. So I'm hoping your issue will be addressed at some point soon, but there is already active work going on to address that question. But, right now, if you look at some of the basic platforms, yes, that's correct. Which business problems it solves in current banking scenarios? So there are many use cases that we'll discuss. So Samir, hopefully, we'll try to get to your questions. But there's hundreds of people trying to solve. As I mentioned, again, that's this slide. You'll see, 3 new applications for blockchain, right after this, since you were on this deck for the last 1.5 years, so 1.5 hours. So there are a lot of use cases that people bring up, but really the litmus test, what I mentioned, is really important, meaning there are a lot of things you could do with it. It's like it's a web platform where you could write logic, and you can build an application. So in that sense, you can do whatever it is that you're thinking on it. But is it really the same platform will be the right thing for it? That depends. to answer your question, so there are several categories of applications that are already in the works, and some of them are in pilot in either Europe or Nordic countries. But there is no real full-blown production platform in North America. Hopefully in the next couple of months we'll see one or two, specifically from Chain.com and Symbiont. But there are several that are in the pilot phase. What we are going to talk about today is 2 or 3 types of applications. One is a simple DLT application. Asad will get to your question as well in terms of what languages. But there are simple DLT applications. So we'll skip that. So these are some of the financial. So we'll share the deck, and you can take a look at these things before later. But there is on the derivative side, which is where a lot of the pain is in terms of current state, in terms of straight-through processing, in terms of settlement, reconciliation, in terms of regulatory compliance. That's where a lot of the focus is, whether it's on DTCC, State Street, or any other big consortiums. They're trying to address the asset classes where there is a lot of manual processes. Nobody's trying to build an equity stock exchange. They're trying to build a private equity exchange by NASDAQ. But nobody's trying to, streamline stock market or anything like that. It should be for more esoteric securities that require a lot more manual intervention and operations, which is where blockchain could be of use. Okay? But there are many examples, as I mentioned, in these in terms of securities industry, securities section here. Private markets is where, and then private equity, there is one. There is crowdfunding environment, and there's a lot of work on record keeping. So the project that we currently started with the U.S. government, Sapient project, that's the first blockchain project, that is on record keeping. So you will hear more about that from our team, both in India and also in Washington. So we'll see the record keeping one. So I was part of the process. So record keeping is where some of the work is getting done, which is kind of that equity derivatives example that you have just seen. So storing transactions, so storing trades. Securities, you will see more. Digital currency is obviously already there. I'm not an expert in it, so ICOs, digital currency, that's already there. And smart contracts is something, it's in the works. There's some pilot work going on that. And then, Estonia has a lot of digital rights programs that are already in production, but that's a small country. So across the board, there is a lot of work that's already done. Some of the digital currency ones that are already in production, and some of the securities and record keeping are coming up. And some of the real smart contract, meaning not smart contract in technology terms, but smart contract in public terms, that will be, in progress. So that should be coming up shortly. So let me look at some of the chat messages. I think I missed some.
Suresh, sorry to interrupt. If everyone can just keep in mind to send your chat questions to everybody instead of sending it as a private message, and then we can read out the question so that everyone gets an understanding of what is being answered.
Yeah. So there's one question on the chat window, which I just answered in terms of logs, how to limit amount of data. So there's already a lot of scanners that are available depending on the platform. Again, there's a lot that depends on the platform that you're using. But it's a valid question, but we're in early stages of that. So nobody's trying to figure out the archiving problem yet. Right? But there is work going on in that. There's also which languages, apps. Yes, we will cover that later in the session. We're not going to talk about the U.S. government project on this call. How to deploy a blockchain app. Yes, we'll talk about that. Client trace performance. Yep. So in terms of performance, I will address that in a couple more slides, but this is not for like a 100,000 transactions a second type situation, so you shouldn't be using distributed ledger for that. There are platforms that are trying to catch up to that, but this is not, as I said, a equity stock exchange scenario. So there are limitations to the by design and the physics of the network in terms of network delay, the bandwidth, the number of nodes, what are the design constraints. So there is a limitation to number of transactions that you could do because it's not like a database that you deploy on your server in your data center. So there are a lot of physical, constraints to be able to scale out, but it's not for everything. Is archiving even possible? Yes, it is possible, but it's not really the way you're thinking about like breaking the chain. But I'll talk about that. Financial regulation signed off on a DL solution. Not yet. Any ongoing projects that attempts to create decentralized banks? I'm not aware of these. I generally don't, focus on the digital currency portion of it. I'm sure there are, but I don't have any answers for you on that. We'll come back to the Q&A again. So in terms of the vendors, so there are these 4 categories of vendors, and obviously, by the time we finish this meeting, this slide will be already stale, right? So because there are so many vendors. So the way we generally categorize it is a Bitcoin or Ethereum-based vendors, meaning they're using Ethereum as a base platform and making updates and upgrades to it. Ethereum, Monax are some of the examples. But that's kind of the open source type environment, and it's mostly for anonymous networks. And there are other open source platforms like Hyperledger, multi-chain, and these are for enterprise applications, but still open source. In the short to medium term, I will probably be less focused on these for companies, but in the long term, like any other platforms, you will get into more Ripple. We're not going to talk about Ripple. I'm not going to talk about any currency, cryptocurrency, or digital tokens of currency in this session. So I'm going to talk about enterprise applications only. The other open source. So those eventually in the long term, there will be a lot more focus on open source platforms like any other technologies. But that would be like Hyperledger, multi-chain, Ethereum, or any other variant of that. But then there's also a lot of commercial platforms that gives you the scalability in terms of transactions, and also they have specific vertical focus, like credits, chain, Symbiont. They have their own focus in terms of what markets they're trying to hit. And they scale, 10, 100, 1,000 times faster than Ethereum and in some cases Hyperledger, depending on the use case. So right now it's kind of, anyone's play, but I think in the long term it would be 1 or 2 commercial vendors and mostly open source as the platforms mature from version 0.8 to version 3.4. I think someone asked a question in terms of the languages and all that, so it's all over the map. But we'll go through some of them in detail in the next 10 minutes or so. In the contract, languages-wise, it's, a lot of the times I use JavaScript or some JavaScript variant, whether we call it Solidity, kind of looks like a JavaScript class. In some cases, you can use just REST API. You don't have to do anything else other than just using REST API. In some cases, we can use command line. We can use Go for the most part for writing some of the more complex logic. And some of the commercial ones actually support Python-based, full Python VM inside your blockchain VM. So it varies, but for the most part, JavaScript, Node.js is the standard stack, and some either Go or some other language. So that would be your typical technology stack. But that's kind of the view on the vendors. Let me see if I have more questions. Third-party vendor management. Yes, I'll talk about that a little bit more, and these are some of the vendors. So we do have an NDA and MSA with most of the commercial vendors. We also talk to some of the open source vendor consortiums. We also talk to open source platforms like Eris. So we have relationship with them from a Sapient standpoint. So we could, depending on what the client need is, we can reach out to them directly, separately as well. The actual platform from Ripple. So I don't have first-hand experience on Ripple blockchain platform. I've just only read about them, so I don't have point of view, but none of our enterprise customers are asking for it. Okay. In terms of marketing, there are a lot of startups specifically focused on marketing blockchain domain. So primarily on your customer engagement, your reward points, and also in some cases using that to leverage some of the marketing consortiums as well. So like a lot of retail, I don't know the details of it, but in terms of primarily customer engagement and rewards, reward transfer, reward tracking, things like that. How do new parties get added to the blockchain? So they need to basically connect to one of the peers and are the main first node that was set up, and they will be able to connect to anyone else on the network. And then there is APIs available to see who is available, how to connect to it, or they can send you a connection information off band, and then you can use that to make transactions on the network. But you'll be one of the nodes on the network. There is no concept of private blockchain. Well, yes and no. So you could have only permission network where everyone is aware of everyone else who is on the network. So in that sense, it's private, meaning no one else can join who does not have access to join. And you can also have private, meaning one-on-one within the network without everyone else getting access to your data, even though they can't really read what's there. So there are different levels of private blockchain, yes. Crowdfunding, that's mostly ICOs. All of the ICOs are kind of crowdfunding anyway, but I don't generally look at them or focus on them. Okay, so we'll come to kind of a more technologist view, right? So one of the things, so there are two concepts I want to make sure that you take away from this session, and these would be the most important things from my standpoint that you would differentiate and understand. One is when someone says blockchain application, there are two kinds of applications. So one is a DLT, meaning distributed ledger only application, meaning the only thing you're doing is putting a whole bunch of text in the transactions. You're not writing any logic, there's no rules, nothing. So examples would be the chat application that we have just seen. So you're only putting a whole bunch of logs, so you're basically logging something to the network. So that's a DLT only application. There are a lot of use cases that are just based on that, right? So there is no code. You're not writing any smart contract logic for it. That is just a DLT-based use case. So we'll talk about some of that. So when someone says DLT only, meaning there is no code, it's only DLT. Someone is putting like a JSON text on the DLT, and someone else can read it who was given permission to read it. Whatever they want to do with it, how is that useful? It doesn't matter from a technology standpoint. It's a DLT only use case, right? So to some extent, Bitcoin is DLT only use case because it only has very minor logic in terms of transferring Bitcoin, right? In terms of digital currency, but this is a DLT only use case. So there is nothing else other than writing stuff to the log that everyone else can access. The second is more interesting for us, which would be the smart contract, meaning not only you are writing something to the log, which is what's called transaction. When someone says transaction, there is no money getting exchanged. Transaction would be a method call, like an atomic thing that you're putting on a ledger. So that's called a transaction. So anything could go on a transaction. But specific to smart contract, when someone says they're writing smart contract, so they're writing a class with methods. So this will be anything similar to your own existing work that you do. This is a very simple example of a meta coin. So this is basically a lot of the ICO code. So you can deploy an ICO with this code, right? So my coin you can deploy, right? The value of that would be 0. It will cost you $2 to deploy it, but this is your ICO code, right? So this is what we call smart contract because any method calls that you make on this color coin contract is going to be persisted as a transaction. And then it's get taken out, that persisted transaction from the BLT, and then the method call will be invoked on your contract. So think of it like old COM, CORBA, like world, where there is an ideal, you're sending a method call, which is a transaction, and then that method call will be applied to your class or object. That's a state machine. So think of smart contract as transactions, which is DLT, plus a method call that happens to change your state. That could be a coin, that could be a value on a form, whatever the case is. So what I would like you to take away from all of this session is transactions, which are just stuff that you put on the network. It could be anything. It could be hello world. Doesn't matter. That's transaction. Or it could be more meaningful that you want to use like a serialized handle for a method call with some variables. So whatever the case is, there is DLT, distributed ledger, and then there is smart contract. Some platforms only support DLT. Some platforms support both DLT and smart contract. And it depends on which use case you are trying to use and whether you need both, how fast you want it to be, because if you have smart contract, obviously it has to do 3 steps instead of 1 step. So it will be slower compared to your DLT use case. So first you need to understand what the use case is, what kind of platform is suitable for it in terms of number of transactions, and do you want to just put in a whole bunch of like logs, like stateless, or do you want state to be maintained? Okay. So if anything, that would be the most important takeaway that I would hope that you would get in terms of what smart contract and what blockchain, when people say stuff, what that means. From a customer experience standpoint, generally, the 2 examples that you have seen, you never would have known that it's based on blockchain. So one of the good things and bad things about blockchain is if you are an application user, you would never know that there is blockchain behind it. That's actually a good thing, but it definitely improves the customer's confidence, and also it will, in some of the marketing scenarios, they feel like customer is actually getting control of the overall experience. So in that sense, it does. But for the most part, at least in capital markets world, they would probably even not know, the end user, that this is built on top of blockchain platform. How is one private blockchain different from a channel in a permission blockchain? It's not really, but it's really a vendor terminology that you're using, Ajay. So there is no difference. You're just using a specific terminology from a client. The implementations, for example, the channel implementation from Hyperledger and the channel implementation of Symbiont are completely different, and each of them believe their methodology is better than the other one. So it's just a matter of what you want to call it, but it's no different. But it doesn't really make sense to have a 2-person blockchain network. Maybe in some cases it does. How much about Microsoft entry? So Microsoft is acting as kind of coming from a cloud angle, not really from a platform angle, as I understand, like in terms of blockchain as a service. And I don't know anything about Hapolim Bank, though. Can a new node which got onto the network read earlier shared messages? Yes, they can. As long as you give access to it. Doesn't validation multiple blocks make applications slow? Yes. So generally speaking, the more the number of nodes that you have on the network, there is a performance impact. But a lot of vendors and even open source platforms are trying to reduce the impact of that by only keeping node types, like validating node, non-validating node in the case of Hyperledger. So yes and no, but generally speaking, yes. Legal concerns, I don't follow ICOs, so I can't really talk about it, but generally on legal concerns, yes. So there is a whole framework by a lot of law firms in terms of how to set up, establish, and use and operate blockchain-based software applications. So there is a framework called DAO, and you may have heard of it, but a lot of legal firms use that framework to set up a DAO network or a decentralized application network. Number of nodes proportional to security of the private blockchain. Not sure if I understand. In terms of cloud and blockchain, for me personally, that's kind of doesn't make sense. It's an oxymoron to call cloud blockchain. If everything is on the cloud, why do you need blockchain? You can just build on cloud, and everyone has access to it. But it's good for development. It's good for setting up your initial network, or you have your own node on the cloud without deploying big infrastructure. And connectivity has always been a problem. But cloud, I would use that as a hosting, but cloud would not make your blockchain platform any different. It will make it easier for you to deploy your blockchain platform. India, yeah, I saw the news. I don't know anything about other than the news. A lot of central banks are trying out the cryptocurrency just to understand how they work. Questions? Okay, I can park questions to the end. Okay, so the two takeaways are like the DLT, which is just how to use the ledger, and smart contract, which is how to program on it. Right? So you could use to use smart contract, you need DLT. If you want to just use DLT, you don't need smart contract platform. Right? So in the example of chat platform, I did not use any smart contract. Okay, and the third one is what we call smart oracles. This is where some of the things that Microsoft is doing with the BOSS and consortiums. The examples that you have seen where there is an application that is sitting where you are entering stuff into it, right? You are typing up, right? In the real world, nobody will be typing up these trades. Nobody will be typing up any of these state machines in terms of it will be straight-through processing. So what smart oracles do is they enable straight-through processing into the network, whatever the network is that you built, without any human intervention. The reason why they're called smart oracles is they're the entry point into your network with an elevated application access, and they are called trusted applications. So they are, they have a private key that they're given access to. They know how to connect directly into the network and provide all the credentials. So think of it like a automated process. Like for example, Bloomberg is sending prices into your network, right? So you have a trade repository where you need to reprice your trades, and Bloomberg is one of the smart oracles sending prices into your network. So think of them are like these extra applications, okay, that are cryptographically secure containers that can do straight-through processing into your network. So those are smart oracles. Okay, so we're gonna spend some time on the code, but before we go to it, let me just complete a few other slides because we may not be able to come back to these slides. We'll spend a lot of time there. So a lot of people ask the question in terms of how do you set it up. So a lot of the technology stack, depending on the platform you choose, which is usually like either Node.js or I deploy it onto Apache as well, but it's usually JavaScript, some sort of backend language that you deploy into your network. Your smart contracts or your function calls that you deploy using its own language, but it generally is a Node.js container or your Tomcat, for example. And then you have another server, which is your blockchain server. Sometimes the Node.js can host your blockchain server. So in this case, there is only one runtime. In some cases, you want to separate them for whatever reason. But generally, a DApp or a decentralized application will consist of your blockchain platform, a set of JavaScript methods, functions, smart contract code, or some sort of JavaScript looking, and HTML application. So you package all three to make it your DApp. And that's what you deploy to every node on the network, right? And obviously, this will be different for different vendors slightly. And how you deploy might also be different because in some cases, you don't want to deploy a 3-tier application that only does form submission. So you can collapse them. You can make it more, small and small footprint. and deploy one Node.js and then do npm start, your entire application will start. Like that's it. And that's a database where you are keeping local information, or you could have a smart Oracle sending stuff into it. So it could get complicated. That's probably why you might want to keep a 3-tier application. But for the most part, a 2-tier deployment would be good, right? Meaning your Node.js, which has your blockchain platform inside, and then your HTML text, not really running on a server, right? Just HTML code connecting to your DApp. Okay, so that's a typical stack, and it could vary depending on how you want to do it. Okay, and then we're going to skip. So we'll go into the code. Before I go into the code, let me just explain, and this will also answer some of the questions you have. So one of the things that I did with Symbiont is a commercial platform, but I used their developer version, let's say, not the enterprise edition, to write that chart platform. So in this case, I used only DLT, no smart contract. But in this case, if you are using Symbiont for your client, you could use Google Golang for your smart contract development, REST API to invoke, and if you want to do more, you can also use Python VM to write your smart contracts and for your REST API. So that's only available for enterprise users. So it's Go, REST, which you could use it with whatever, JavaScript, Java SDK, whichever one it is, and Python. That's the stack for Symbiont. And you can mix and match. The chain.com, which is actually a lightweight smart contracting platform. So it uses its own contract language called Ivy, and I'll explain what that is. We'll go through some examples. And then they have a Java JDK. So you want to integrate with it, with your web application. And you can deploy to Tomcat, which is what we did. Ethereum, which is a more open source version. So there are a bunch of smart contracting languages available to deploy, but Solidity is the most popular one. And JavaScript is what you generally use for most of the functions. It has a command line console, and it has a JavaScript framework to be integrated into your web application. So if you're using Angular, React, or even just Bootstrap, Ajax, you can integrate with their web3.js, which is their JavaScript platform, to connect to the blockchain server, so to speak. So that's the typical stack, and it really, varies in terms of what use case, how complex you want to make it, but they all support, most of the scripting tools for DevOps, for deployment, a lot of command line tools available from them. So, I'm going to demo mostly everything with command prompt, like DOS and, REST API. So you can do all of your deployments relatively straightforward. So again, with all of these examples, as I said, like by the time we finish our meeting, there will be like 7 other announcements on blockchain that we might have missed, right? So are the contracts always written in Java derivative? I don't know what that means, but if JavaScript, Solidity, and Golang are considered Java derivatives, then yes. But I would say, for me, it looks like, Go almost looks like, COM Corba for me. So that's like C, C++. And Solidity looks like JavaScript, and Ivy would look like something else. But if you're a Java developer, you would be fine writing any of these things. Okay. So that's all with the deck. And, either me or Vladimir will share the deck with you so you can read offline. Primarily, I have some references for everyone to read, and these are some of the things that I found useful for writing applications than just general knowledge. And some of the Khan Academy ones are much more intense in terms of cryptography fundamentals, but I believe that's good to understand. So that you can take a look at offline. Do we need additional plugin for Node.js to integrate with blockchain? Depends on the platform, but generally the blockchain server itself, that will work with as part of your Node.js deployment. So any other things, I don't think so. But I haven't worked with every single platform, so I don't know. So there's already, so Ivy is one of the descriptive languages. So Short answer is yes. And some vendors actually believe that's the right way to go. So like, for example, chain.com is a declarative language for writing smart contracts. So we'll show some of the examples of that. So let me stop that. So we'll start with kind of a simple one. So you looked at the chat window, like this chat window that we did. This is like my own example. But here I'm submitting this test chat. But really what's happening behind the scenes is it's actually sending a REST API request to submit the chat message to the DLT platform. And how the DLT, that particular DLT platform would look on the REST API side. So this is how it looks. So I have some chat messages that I copied, right? So it will show me the transactions which are chat messages. So this is how it's stored. It's stored as JSON. Every chat message is stored as JSON. What you see as data is your hash, is your hex encoded. This is not encrypted. In this case, I had a hash encoded data, so anyone can decode that. And then I have a hash of that particular message, so no one can change it. And then I have a state hash, which is same as the block hash for the previous block. So in Symbiont, it uses previous set of previous hashes plus the hash of this to create this state hash. So in this case, think of every transaction is its own block in Symbiont, right? So that's how they implement. So my concept is still the same in terms of multiple transactions make up the block. In this case, that multiple happens to be 1. And then you have the hash plus the previous hash is a state hash. So it's a chain. So this is an example, and anyone can submit a post to your postman and submit a message to the network. So it's available through REST API. So in this case, I could do REST API, or I could write a small Go program, which let me find. So I'll write a small Go program that says, that call the method called append transactions. And then I'll just send the text. And I used a channel called Sapient Chat to submit the text. And then I submitted the text, which is hex encoded. And then I used a Symbiont assembly import to the client and a scanner to read. So it's a Go program with 3 imports other than the formatter and all that. And then 1 method call. So this is very simple application where I'm calling just append transaction method and writing in a transaction to a distributed ledger, which would look like that. Okay. So this is a very simple example. In this case, I could use REST API. I could use Golang from command line to type up the message. Okay. So that's one example. So there is no smart contract here. So I did not write a contract. I did not write any methods, business logic, nothing. I just said append transactions. That's basically what it is. So there's some detailed messages here, like BDD I answered. Transaction gets, so all of these transactions get stored on file system, like to be honest, right? And some vendors use different platforms to store the database, local database. For example, I'm running here Postgres for chain, which we'll get into later. So in some cases, some of the commercial vendors use some other databases to store the chain and the hash and everything else related to that. Not only the metadata repository, but also the data repository would be in Postgres in this example. But depending on the platform, they use different methods. But in most cases, when I go to the data folder on my server, it's just a whole bunch of files. So, but in some cases, I can actually query the database. I can log into Postgres in terms of this chain.com platform, and I can query some tables. I don't know what's in these tables, but I usually just go through the REST API. But the database in the case of chain.com is Postgres. And then there are, Hyperledger uses 2 different types of database options. You can plug in any other RDBMS if you want. And it can store, and it can also store NoSQL. So like it also supports, I think it's called HiDB, I forgot the name of the DB, which supports like graph queries and things like that. So short answer is yes, databases will be there behind, but you generally don't get into the database. You can, but there is no need to. Real-time replication, yes, there are many challenges with real-time replication in a decentralized system, and there are many algorithms and optimizations that people have done to make it faster as they can, but that's an evolving field, and generally I can't keep up with it, and I'm not an expert in it. I try to focus on the application development, but there are some challenges, yes. What qualification is required to get into blockchain? You just need to spend more time on it, try to figure out what it is. A lot of the times it's the documentation that trips you up. You just need to spend more time figuring out the syntax because it's not available directly as is. Even from chain example, I didn't know exactly the sequence in which I need to set up the Postgres database before I start my chain server. So it's just the documentation and spending more time, breaking your head. But otherwise, it's Java, JavaScript, some C maybe, depending on what it is. And if you know JavaScript or a full-stack developer on the JavaScript, or you are a Golang developer, then you have it easy. So there's a lot of things directly available for you. Okay. So the next example I want to see, so I don't think there's any other questions here. So in this case, as I mentioned, this is a simple append transaction or a simple post REST API to actually submit a transaction with a text message, right? That's it. There is no smart contract here. So the next example I want to show is more, the equity derivatives that you have seen. So this is a equity derivative smart contract. So I have all of these variables so this is a Solidity language contract. So this is a smart contract, meaning I have state machine and I can call some methods like setters, getters, business logic, whatever it is that I want to call, validate price, and then I can have events which are emanated in the network by some other method, and I can listen to those and I can take actions. So it's like me calling a Java object, right? Right. So in this case, I have a contract which I've written in Solidity called equity derivative. It has a enum, struct, some functions within the contract, which are getters and setters, right? So it's simple. And you can call this particular contract, instantiate it. You can put data in it, and you can have a list of these things that you get if you want, right? If you have many trades that you are putting in on the network. And you can also give access to them based on specific owners, based on address. Each user will have an address, right? So you can refer to the nodes with their address. So only give access to this address or that address, or only if the address is in this list, give them access if you want to do it. If it's a permissionless network, you can't do anything with the address, but everyone will still have an address, right? So they can do whatever they need to do. But you can assign state based on the address. So address would be part of your array index. So you can give address-specific state. So only that particular guy with that address can see that data. But otherwise, it's a, let's say, Java class or a JavaScript class. And any method that you execute on it, it becomes a transaction. So set contract, which is a method call that you make. So I'll show you where I made it. Not sure if I have it here. So I made a method call here using a JavaScript framework from my web application. I'm not a web developer, so don't comment on my code. I made a call here. So each of these send transactions, set GSA reference, set email, whatever the setters are, all of these become a transaction on the DLT, which would then be taken out of the DLT and applied on your class or your object or contract to make sure that it actually changes the state of that. And if you want to listen to as a callback, you can. So you'll wait for it, but you can also listen to the callbacks. How long is the life cycle of a transaction? That's a good question. So it depends on the platform. I would say, in the Ethereum world, it could be like 20, 30 seconds. And in some of the commercial platforms, like half a millisecond, a second, depending on how many method calls you're making, then you say it's a transaction, depending on what you call transaction. Right? So you could be calling 15 methods, and you call it a transaction, and that could take some time. But generally, we're not talking microseconds. We're talking milliseconds or seconds. So this is an example on the smart contract, but this is I have another example which is a stock custody. So like what State Street does, I could implement a decentralized custody. So we have an example that we did, like not really client-friendly application, but I could have a custody platform, decentralized custody platform, where I can send my stock to other participant on the network without having a central counterparty. So this is a decentralized record keeping for your stock. So think of it like a DTCC for you, right? But DTCC is trying to build something like this using their own internal platforms. So because they are a record keeper of stocks, but you could implement a decentralized one where you don't need a centralized counterparty for custody. So in this case, again, I have some state variables, types of stock, a bunch of add custody, remove custody, transfer custody methods, and that's it. Right. So this is another smart contract. It's doing a little bit more than the previous one, which is just a getters and setters. Right. Again, this looks like a combination of JavaScript and C programming. Miners can see transaction. So we're not going to talk about miners because, other than some of the public platform networks, specifically only with Bitcoin at this point, you probably don't have to worry about mining, but you should know what it is. But none of the commercial platforms, none of the enterprise platforms use mining, right? So that's only for. And then I'm not a Bitcoin expert, but there is nothing there that is not confidential, meaning you don't know anyone there. You only know what the transaction is, but you don't know anyone. So in that case, it doesn't really matter in the case of Bitcoin. But otherwise, you don't really see the actual data, and there are a lot of platforms that can actually do cryptographic. You can do additions or subtractions on your assets without knowing what the asset is. It's called the homomorphic encryption methods. So to answer your question, I'm not a cryptologist, so the easiest answer I can give you is no, miners won't know anything about what it is, and it doesn't really matter for us. Lifecycle of the transaction really depends on what kind of contract code you have. Like in this case, add custody details. That's a transaction. Where I'm taking a custody of a stock and then I'm adding it to my array of state. Or I'm sending custody from one, I don't know where that is, sending custody from one address to other address. That's the transaction. Right? So block vanished. Well, nothing should vanish. Again, I wouldn't worry about, as an application developer, about block, hash, transaction, confidentiality, because we have enough things to worry about as an application developer. We'll just continue working on application developers. So if you are a cryptologist, you are a mathematician, you should go find out and read all these things, but I don't know the answer to the question. Have you seen that transactions are lost as seen in TIPCO or during Corba days? As you are doing development work, yes, I have seen it, but it's usually some permission issue or something like that. But I don't know if the total enterprise grade exception management, all that stuff is built into all these platforms. But I've seen it in the open source ones, but it's usually my mistake, and they don't really give the right event, and I have not captured the right event, probably whatever the case is, but I've seen some updates getting lost. But I'm not going to go out and say people lose transactions on blockchain. So let me show a few other examples. So there's one more example I want to show, which is a little bit more heavier. So I want to talk about this platform called Chain. Let's see if I can actually figure it out to bring it. Okay. So Chain is a platform that is a commercial platform, and I have a developer version on my local. It is actually an asset transfer platform. So it is not a full-blown smart contracting platform, Now it is just a raw DLT platform. It's somewhere in between. So this platform is, so NASDAQ is going to go live hopefully in November with their first private equity on blockchain using chain.com platform. It is primarily used for asset transfers, meaning if you don't have asset, you're not using chain. You need to have an asset that is either native to the platform, like Bitcoin, or it is a digital token of something that you already have outside that a separate person can vouch for. So you can say, you can come into the platform, I say I have $1 million. It's not going to be of any value unless a bank tells you, yes, you have $1 million, and whatever trades you do on that, it's going to be becoming your real US dollars. Then only it becomes a valid asset, like a token. Right? So this is a token management platform, just one way to put it, but it's not a smart contract language platform. So this is allowed to do fast asset transfers or digital token transfers. So it will reduce the settlement time. It will reduce some of the complex trades to be done in more transparent and more, options for trading, like, for example, auction-based second lending, reverse second lending, whatever the case you want to do it. So this is only for asset-based platform. And their smart contract language is slightly different. I think someone asked the question, like a declarative or BDD. So this is not entirely like English written, but there is no language, there's no code that you have to write other than this contract that you have to write. It's called IV, and it is very similar to Bitcoin's smart contract in terms of the way the data structures are used, which is the UTXO. So in this case, I could do a SEC lending or a loan collateral transaction without writing any code, but it kind of looks like a code, but what they call is a declarative contract, a lightweight contract. So I can give a asset that I have. So I can say, I'm going to give, like Alice, I'll give gold. I have 990 units of gold. I'm going to give 100 units of gold to someone else, and then I would like to get 500 euros for it for whatever term that is due on this term, and then Bob is going to give me those $500 for these 100 units of gold. So this is a trade platform, like a digital token-based trade platform. So in this case, the smart contract is much more declarative because you're doing something very structured. Based on what you write here, the REST API will allow you to send the JSON object for it. Right? So it's still a smart contract, meaning smarter than a DLT, but you're not writing any code. And then you can submit the trade itself using JSON based on this language. Hopefully I'm making sense. But so think of it like a lightweight smart contract, not a full-blown language. Right? Versus Hyperledger, Ethereum all have full-blown languages. Whether it's Solidity, whether it's Go language, whether it's Python with Symbiont, these are like full-purpose contract languages, like what they call general-purpose language. Versus these specialized ones are only done for a specific purpose because chain wants to focus only on asset transfer use cases for blockchain. And it could be anything. It could be SEC lending. So what we built, I'll show you an example of an application we built on top of this smart contract. But we can build securities lending. We could do escrow. We could do asset, custody. We could do on demand. You can do event-based transfer. You could do options. Anything you want to do, you can do it. As long as there is an asset involved and there is a contract language that can allow you to transfer that asset to someone else cryptographically. For example, trade offer. So there is a public key of the guy who is actually offering, in this case, gold, and then you actually use the other guy's private key or public key to sign the trade, so that when the other guy gets it, he can actually verify that you sent the trade to them. So there is a public key on one side, and then the signature of the other counterparty on the other side using their own public key. So it is cryptographically sealed trade or transaction. So no one else can say, I have done it or I have taken it, because I've already told you who I am and I've already told you who you are. So there is no one else who can get into the middle of the trade. Right? So each contract will have a public key and a signature. Okay, so that's more, so I'll just show quickly the example of asset transfer use case. I know we have 15 more minutes left. So what we built in New York is a platform that is built on this chain, which we just seen. We created like these 4 banks, and each of these banks have some stocks in their portfolio that someone else vouched for, and they want to do securities lending. So we built a front-end web app that uses REST API to connect to chain platform, and basically allows you to do these securities lending with whoever else that's on the network. So you don't need a prime broker, you don't need an agency, you don't need anyone. You can do bilateral securities lending transactions with each other. Or you could do an auction, you could do reverse auction, you could do group security lending portfolio. So in terms of the strategy to do your trade will be in your own hands, going back to the customer experience comment. Okay. So this is a decentralized securities lending platform. And you could also do, loans. You could do loans based on your stock portfolio. Like let's say you have an E-Trade stock portfolio, you want to get a loan. You don't need bank, you don't need anyone else in the middle. Let's say a buy-side guy can give you a loan without going through any other intermediate bank. So in that sense, it's a powerful platform, even though you're not writing a single line of code other than a declarative contract. So in this case, our front end is kind of raw front end, but it uses the REST API by chain.com to submit the contract calls and also the transactions. And they also support Java API if you want to use on the back end without using REST API. Okay. So that's all I have. So I'm going to pause here and see if there are any other questions. I don't have any other material to cover. Hopefully this was helpful. There's a question on security scan, performance testing. Yes, you can do performance testing. I'm not sure about, I'm not a security guy, so I don't know what security scan means, but you can scan it. Performance testing, absolutely, you should be able to do it. I can elaborate on how a new node catches up with all the transactions. Yeah, it's a long conversation in terms of catching up. You don't need to catch up. If you want to catch up, you can. But that's underneath the platform. Like there are several protocols: Whisper, Sync, and then there is one more. That will allow you to catch up. Node goes offline. Is there an impact? No. So it's not only the node goes offline. Its blockchain supports what's called Byzantine fault tolerance. What that means is not only if one node goes down, it's fine. If the node is behaving badly, meaning there is a rogue node, even then nothing would happen to the network. So it's not only failure tolerant, it also is Byzantine tolerant. That's what that means. Like you can try to hack it. One node is like trying to do some malicious things by trying to put in transactions on behalf of someone else that no one else can verify. So even then, the network is still secure and available. Okay. Is there a time frame when the seller do not accept the transfer? Yeah, that's a very good question. Chain supports a lot of different triggers and events to cancel or roll back the locked value of that transaction. Yes. There's only one smart contract code that gets deployed, so not everyone can deploy their own code. So yes, it needs to be agreed with the counterparties before you deploy the contract onto the network. And generally, like people, whoever is developing the contract, probably from the group, but not everyone needs to make the method calls directly. They could make a REST API wrapper. They could make a form that someone is entering, so they don't particularly care about the method signature, but you should, like everyone on the node should agree on what the method attributes are. Okay. Genesis block. Well, on a private network, yeah, I've created it many times. I'll try and find it on my network. But if it's a public network, it's already done. If it's a private network, yes, you will create your own Genesis block. But that concept itself is not applicable to all the vendors. Like, so it's a lot of the times it's a very Ethereum-ish terminology. But yeah, anyone can create if you're creating your own local network. Blockchain supports sync and async. Short answer is yes. Yeah, you can have sync, obviously, because it gets onto the DLT. Async in a slightly different sense in terms of events. But to get your transaction onto the DLT, it will be sync. But you can receive a async response, or you could receive an async event by event handling. So partly yes to your answer, to your question. Okay. If there are no other questions, and Vladimir, if you have any closing comments, we can do that, but I don't have any other material.
Okay, perfect. No, thank you so much, Suresh. That was very informative. I'm sure a lot of people walked away with more knowledge than from the first session. Thank you, everyone, for joining.